Welcome to Science News Review. For August 12, 2026, we are looking at the staggering scales of our universe, from a galaxy that dwarfs the Milky Way to the concentrated carbon footprint of our world's busiest rivers, and we ask if an AI might soon be the one deciding which scientific discoveries are worth your time. We begin in the deep reaches of space, where new analysis is helping us grasp the sheer scale of the universe's largest structures. Astronomers have been looking closely at IC 1101, a massive galaxy located over 1 billion light-years away within the Abell 2029 cluster. Using deep exposure images from the Isaac Newton telescope, researchers have been able to more clearly define the boundaries of this cosmic giant, distinguishing the galaxy itself from the diffuse, glowing material of the surrounding cluster. The numbers are difficult to wrap the mind around. IC 1101 has an estimated diameter of nearly 1.7 million light-years. To put that in perspective, you could line up 17 Milky Ways end to end and still not reach the edge of this single galaxy. It is a member of a specific class of objects known as brightest cluster galaxies, and it contains roughly 3.4 trillion solar masses of stellar material. But these giants don't stay the same size forever. Astrophysicist Carlos Marrero de la Rosa notes that IC 1101 is still actively accreting material through mergers. This is a process often called galactic cannibalism, where a massive galaxy grows by repeatedly absorbing smaller, neighboring galaxies. It's a slow, gravitational feast that has shaped IC 1101 into the behemoth we see today, and according to the data, that growth is still ongoing. Moving from the scale of galaxies to the scale of our own planet's logistics, we find a surprising trend in how we move goods across the globe. When we think about the environmental impact of shipping, we often picture massive container ships crossing the open ocean. However, new data suggests that the most significant climate impact might be happening much closer to home in our inland waterways. Our rivers and other inland waterways make up less than 1% of the world's total navigable waters. They carry a disproportionately heavy load when it comes to carbon emissions. In 2022, these waterways accounted for nearly 1/4 of all carbon dioxide emissions produced by the shipping industry. The impact isn't spread evenly across the globe either. It is highly concentrated in specific, high-traffic corridors. In fact, just 20 high-traffic river systems, with China's Yangtze River being a primary example, contributed almost 70% of all vessel emissions during that year. This suggests that if we want to address the maritime industry's carbon footprint, the most effective targets might not be the vast oceans, but rather these specific, densely packed river arteries. Finally, we turn to the process of science itself, and a question of who or what gets to decide what counts as a breakthrough. As the volume of scientific research grows, the traditional system of peer review is under increasing pressure. To help manage this flood of information, a Tel Aviv-based startup called QED Science has developed an AI tool designed to evaluate the originality and validity of life sciences manuscripts. Unlike a human reviewer who might be influenced by a researcher's reputation or the prestige of their university, this tool is designed to look strictly at the relationship between a paper's claims and its supporting data. It's currently being piloted by the non-profit OpenRxiv on its Bioxiv server, and it has already seen use in over 1,000 institutions across 70 countries. In a validation study of nearly 3,000 preprints, the AI was able to identify a subset of papers that it rated more highly than the eventual peer-reviewed journals they were published in. When a panel of human experts reviewed those specific papers in a blinded test, they agreed with the AI's assessment 75% of the time. While the developers say they aren't currently selling this service directly to journals, the technology is sparking a significant debate. Some researchers are concerned that an autonomous scoring system could create an opaque, metric-driven culture in academia, where scientific truth is determined by an algorithm that lacks transparency. The central question remains whether an AI can ever truly replicate the nuanced judgment required to validate complex scientific discovery, or if we are simply trading one set of human biases for a new, digital kind of gatekeeping. Whether it's the massive scale of a galaxy or the concentrated impact of a single river, science shows us that the most significant details often hide in the sheer size or the specific concentration of the data.